R using ggplot. You can find Code of Conduct on the website. We always broadcast these live on YouTube, so if there is ever an event that you can't attend, you can always go to that broadcast. In the email that you get, there's a link to the YouTube broadcast. I'd like to thank MedLab, which is this wonderful space where you can do all this really cool 3D printing and other stuff, and they host us. I have an attendance sheet. If you haven't signed it already, I'll keep passing it along, and please do sign in. If you'd like to instruct or otherwise get involved, you can talk to me or to Ahmed at the end of the lesson. If you have any questions throughout the course, just raise your hand and I'll come to you and help with whatever might be troubling you. All right, so I'm Margot. I'm a fourth-year grad student in molecular genetics, and I'm part of the ggplot2 Council. You guys, and I work in R and Python, and I got involved at the start of my graduate degree. If you'd like to introduce yourself, and then we'll go around it.
We usually always start with introductions around the room, so we know where everyone's at with R and.
Hi, my name is Anne. I'm a new PhD student in the pharmacology department, and I work with some genetics and imaging data. It's my first time here, and I do have a bit of introduction to R from before, but I don't use it on a regular basis. So
I'm Zoe. I'm a first-year master's student in the Department of Nutritional Sciences, and I've only worked with R a little bit in a biostatistics course where I do work with R and microRNA and genetics.
Awesome.
Hi, I'm Charles, and I'm a postdoc at Princess Margaret. I've taken introductory courses to R, but I don't use it frequently enough that I'm proficient in it, so that's why I'm here.
Great. Yeah. Hey.
Well, I was here last time.
Yes.
I'm CL I'm a first-year PhD student. I'm interested in programming, and that's why I'm here.
Great.
Hi, I'm Constance. I was doing some graduate coursework in machine learning here, and I just want to be a bit more proficient in R.
Awesome. Great. Well, thank you everyone for coming by. I'm Ahmed. I'm also on the U of T Coders Council, and I'm a big fan of R. I started using it around the time I started grad school, and I've grown to really love it, and doing all sorts of data analysis and plotting in it. And today in particular, we'll be covering plotting, just like what you're here for. So it seems that most people in this room are relatively new to R or have some experience with it, which is fine. That's kind of the exact level we'd hope for you guys to be, because that's what this lesson is kind of aimed at. And today what we'll be doing is plotting, specifically using a package known as ggplot2. So you may have heard of this, and you may have also wondered what the GG stands for. ggplot2 is an implementation of what's known as the grammar of graphics. And this is kind of this I don't want to say newfangled, because it's actually quite old now, but this way of thinking about visualizing data at a bit of a higher level, in the sense of telling a programming language, let's say R in this case, hey, I've got this data set, put this on the x-axis, put this on the y-axis, and color my points by this z variable. So kind of expressing instructions at a relatively high level and having the programming language, in this case R, understand what we're asking for, as opposed to doing something that's a bit more programming heavy, such as, I don't know, writing some sort of loop or complex function to add points iteratively. So the idea behind ggplot2 is to really simplify the plotting process and allow you to express kind of really complicated plot commands, let's say, with relatively straightforward syntax. It's something I love a lot. I got a ggplot sticker on my laptop, so I'm really excited to get into it. So this here's our studio. For those who have not encountered it before or are relatively new to it still, we'll just quickly tour through the interface here. So you should see at least 3 panes looking somewhat like this. There is a console pane. This might be at the bottom of your screen. And this is where we actually interact with R for the most part. We would type in commands, R would interpret them and do its thing. On the left here, and this might be on the right of your screen, I've reorganized a few things. This is an environment tab. It actually stores some of the objects we'll be making along the way. I won't be using this as much, so I'm going to be minimizing it. On the top left here is the source panel. If you don't see this, then you can click on this icon on the top left to create a new R script. And the source script is essentially kind of this, it's a text file environment. You can write code in it, and then from here you can send code you've written to the interpreter to be run. So it allows you to write more than, let's say, just one line at a time. Finally, down here is a bit of a catch-all pane. It contains files, any plots you make, so we'll be seeing this a bunch, information on some packages, and so on and so forth. So I'm going to minimize the environment tab over here. So to get started, I would go to the top left over here and just click on New R Script if you don't already see this panel. If you do see this panel, then that's great. But clicking on this should open a window that looks something like this. So over here is where I'm going to be writing my commands. And the nice thing about RStudio is you can write commands here. So let's say 5 + 5. And then by pressing Control Enter or Command Enter if you're on a Mac, you can run a given line of code and have it show up here. I'm just mentioning this now because this is what I'll be doing throughout the lesson. I don't want to look like I'm, just not even typing up code that I'm running. So with that out of the way, let's actually talk about ggplot2. So has everyone installed ggplot2, i.e. run this command over here? This was mentioned in the email. If you haven't run it, I would definitely recommend running it now. It might take a few seconds, up to maybe about half a minute. But if you've already run this, then you're pretty much good to go. So in R, a package we might remember, or might have analogous experience in other programming languages, a package contains usually a set of functions. So a set of functions that allow us to do a particular thing. So ggplot2 provides us with a series of functions we can use to plot naturally. But those functions aren't actually available to us from the get-go. In order to actually import those functions into R, we have to use the library command. So notice as I'm actually typing up library, R will suggest the function for me. So library in itself is a function. And we will use that to load in ggplot2. When I run this, again with Command Enter, we run over here and it won't actually output anything. But now the ggplot2 functions are actually ready to use. Okay? So the other nice thing about R is it actually comes preloaded with a series of built-in data sets. This means that we don't actually have to read in any data. I didn't have to email out any data. There's already sample data sets within RStudio. So we'll be working on one of these called diamonds. And we can have a look at diamonds just by typing in diamonds into our console or into our source panel over here. However, since it's a large data set, we're not just going to run diamonds on its own. We're going to run head and then diamonds. The head function, this was covered briefly in last week's intro to R lesson, the head function will just print out the first few rows of a data frame. So let's just do this to take a look at our data frame over here. So if I run this, I can get a sense of what's inside this diamonds data frame. So diamonds contains about, I think in full it has about 50,000 observations, which is quite a fair amount, regarding certain diamonds involving stuff like their carat, how much they cost, what their color is, alongside some clarity measurements and so on. So I'm just going to say this right now. If you have a slightly older computer or you're worried about kind of plotting 54,000 points at once, you can make a subsetted version of this data frame for yourself if you feel like these commands are running slower. So I'm just going to type that out now. You could always come back to this. We'll call this D head diamonds, comma, n equals 1,000. So there's a lot going on in this line. It's not really the focus of today's lesson. But this command will create a new object called D, which just contains the first 1,000 rows of diamonds. You don't have to do this if you're just worried that your computer might be a bit slow. And if you've got, say, a MacBook like mine, or a computer that you got in the past few years, you should be fine. But otherwise, this command might save you some time. Okay? Any questions before we actually start plotting? Cool. So plotting in ggplot always starts with the ggplot function, as the name might tip you off to. So this is ggplot without the number 2. It's just ggplot. Once you type that in, the first argument or input to this function is just the data frame that you want to plot. So I'm going to write up diamonds over here. You could also write up D if you're using the smaller version of the data frame. If you run this command on its own, you're going to get pretty much nothing. because we haven't told it anything else. We've just told ggplot, hey, we're going to be plotting this data frame. We haven't said anything else. So naturally, when you look at a plot, what are probably the first things you notice besides pretty colors? I notice pretty colors. Likely, you're going to be drawn towards what's on the axes, right? Plots are essentially visualizing relationships, and you care about what these relationships are between. So before we even tell it how to plot what we want it to plot, we have to tell ggplot what we want on the axes. So the ggplot term for this is the aesthetics. So the aesthetics can be provided as a second argument to the ggplot function. So for our second argument, we're going to type in comma. Sorry, do you have a question up front or no? Oh, no worries. So here we're actually going to have a function within a function. We're going to type in AES, short for aesthetics, and then open a set of parentheses again. So the aesthetics function, it doesn't really do much outside of this ggplot context. It only really exists to be run within ggplot. It's an example of a helper function that way. And here, you'll notice RStudio is actually suggesting this for me. It's telling me, what do you want on the X? What do you want on the Y? So on the X-axis, to begin with, I'll say I want to look at the caret of these diamonds, comma, Y equals price. So essentially, let's look at how price varies by caret for all these diamonds. All right? Now, we can try running this line of code. And we still haven't really plotted anything, but we can clearly see that ggplot is sort of primed at this point for something to show up. We have the axes. We don't have any points, any lines. But we do have price on the Y and caret on the X. So the final piece of the puzzle over here is at the end of this ggplot command, add a plus. Hit enter. You'll notice there's a bit of an indent over here. And then type in geom_point. And then with your cursor anywhere on these two lines, just hit Control Enter, and it'll run both lines at once. This will take a second because it's a large data set, and boom, suddenly we've got 50,000 points plotted. So what's happened over here is the term for, I suppose you could say, ways of plotting something in ggplot is known as geoms. So bar plot is a geom, histogram is a geom, and we'll be looking at some of these geoms later on. But geom point is a geom for a scatter plot. And what we've said here to ggplot essentially is put this on the X, put caret on the X, put price on the Y, and then use the point geom to plot it, which seems like a really roundabout way of saying make a scatter plot out of these two. However, we use this plus operator because ggplot is about building plots iteratively, and we'll see more of that in a second. The idea here is that you create a ggplot function up top where you define what you want to plot, and then you add layers to it. So the only layer we've added so far is point, so essentially make a scatter plot. Something I want to mention before we actually get into more layers is the position of the plus is pretty important. If you actually put the plus down here, I'll actually leave this up and copy this down. If you don't have the plus up here, but have it down here instead, ggplot will raise an error. It needs the plus to be at the end of a line. If the plus is at the start of a line, like this, it won't know that these two lines are linked. So always be careful to have the plus at the end of a line. I can leave a comment for myself here using the hash character. This is wrong. Put a plus at the end of a line. And you're obviously welcome to keep commenting your code as you go along. Any questions so far? Awesome. One other useful thing, and this will kind of go hand in hand more with as we add more layers, is that you can actually save all of this to an object, or save any part of this to an object, and then add more layers to that object. So if I don't want to type out this whole thing every time, I can save it to an object. I could call it, I don't know, P, short for plot. Then use the R assignment operator, so that's less than dash, equivalent to equals in most other programming languages, to create a new object called P. And we will write those same sorts of settings. So ggplot diamonds, comma, aesthetics, X is caret, Y equals price. Once you run this, nothing actually changes, nothing is actually output to you. But if you were to type in P plus geom point, it actually will take a second again, but it's going to print out the exact same plot. And the reason is this down here is equivalent to this up here. We've essentially just shortened the whole kind of ggplot global settings, you can think of them that way, into a single object called P. So this is often useful if you're going to be making several different kinds of plots using the same sort of base settings, if you were to think of them that way. Does that make sense? Awesome. Okay. So one thing that ggplot is really kind of excels at is this ability to build plots iteratively. So I might see this plot and, like I said, might want to change something about it, might want to add layers. And one cool thing about RStudio, in fact, is these back and forward buttons actually let you scroll through the plots you've made. So you can actually go back and see what the previous plot looked like compared to your current plot. So with this, I want to mention that geomes, you've noticed that here I just had an empty set of parentheses. Geomes actually take in custom arguments of their own. So a really commonly used one, especially in genomics world, which is what I work in, if you've got an absolute ton of points and you find that they're almost too dense to actually make much sense out of, you can actually reduce the opacity of these points in order to see clusters better. So you can control this using an argument called alpha. So if I were to type in alpha equals, now alpha will range from 0 to 1, where 1 is completely opaque and 0 is basically transparent. So I could give this an alpha value of 0.5, let's say, and then run all of this. And you'll notice that some of these points are a bit more transparent now. You'll notice that over here, this cluster is a bit less dense than the previous plot sort of suggested. But you'll also notice that over here, it is just as dense as the original plot suggested. So this is a good way to kind of reduce overplotting and maybe see clusters in relatively large data sets better. You can also toy around with different alpha values. You can crank it down to 0.1 if you'd like. But it's a really helpful kind of setting to know. There's also various other arguments, but we'll get into those a bit later on. So now for this next bit, I'm actually going to switch back to the main. I'm going to copy this line of code down because I'm going to alter stuff in our global settings up here. Okay. So you'll notice that there appear to be some clusters in the data, right? And there's clearly a chunk over here, this weird line subdividing these two, sort of banding happening in our data. What if some of these clusters could be explained by a categorical variable in our data, right? We got stuff like cut measurements, clarity measurements. So it could be that, let's say, the cut of a diamond is a strong determinant of its price. So a really good way to actually explore that visually is to add a new aesthetic, and I'm doing this up here in the AES function called color. So price, comma, color equals, whoops, cut. It's being a bit cut off in my screen, but there's still a plus at the end over there. And what this will do is it's telling ggplot that, again, put caret on the x, put price on the y, but color the points by the cut variable. And automatically it'll assign colors to it. These might differ based on your version of r/ggplot. I think mine is set to the Veritas template. But it'll pick colors for the various values of cut or levels of cut and then shade the points accordingly. Does that work for everybody? Isn't that pretty neat? That being said, what is less neat is the fact that cut doesn't seem to explain much. It's kind of this hodgepodge of colors, and it's really not telling you that much about the clusters or why the data is clustered the way that it is. So maybe let's try a different variable. Let's try to shade them by clarity. So I'll just write this out again. Diamonds, aesthetics, x equals caret, y equals price, color equals clarity, add a plus at the end, and then the only geom is geom point. So it's the same as the command I just ran, except I just switched out cut for clarity. I'm just typing them out so you guys have both up there for reference. We'll scroll a bit so you can see the plus at the end.
So
Sure.
before when you were using alpha, what was the difference between the dots that were lighter and the ones that were darker?
So with alpha, actually all the points were made lighter.
Oh, it's
So
just
if-
like the overall?
Yeah, so if points look darker, that actually meant there was multiple points there. Yeah. So that just goes to show how dense this data set is. But
So sorry, I didn't quite understand. I saw the offer is a significant, statistic significant, but you said it's just make all the dots
Sorry, the alpha?
Yeah.
Oh, right. I know what you mean. Alpha is also used to denote statistical significance, but in ggplot world, alpha just means transparency of points. It doesn't refer to statistical significance
Okay,
at
so
all.
it's transparent all the plot,
All the points.
dots.
It doesn't do any kind of statistical test. It's not like, oh, this point meets a critical value or something.
Okay.
Yeah, so it's just 0 means transparent, 1 means opaque. But yeah, I know alpha means the same thing in both contexts, but it doesn't have to do with that.
And
Another question?
also, after assigning that first line to P, does it not matter anymore whether P and the second layer is on the same line?
No. I mean, even with this full thing written out, you can still keep them on the same line,
Oh,
but it's just easier to break them up just for visibility. The only reason I actually stop using P is because I'm changing the color aesthetic. Otherwise, I would keep using P.
oh,
But I wanted to point that out just so you guys know, just so you don't have to keep on typing out the same thing. But yeah, so if we plot with clarity as our coloring variable, I'm seeing a lot clearer clusters over here. And so I actually looked up what these random combinations of letters and numbers mean. And apparently it seems that IF1 is the highest clarity and I1 is the lowest clarity. So it shows over here that IF, where'd it go? I think it might be a little bit cut off, but IF diamonds are all the way on the left side of the plot, where even for low carats or carat values, they fetch super high prices. Whereas the I1 diamonds are over here, where no matter how high they're, or not no matter, but even with much higher carats, they still have lower prices than some of this upper cluster of points. I'm not really a diamond scientist, but the idea being you can use the color aesthetic to kind of observe clusters in your data. In almost like in a sort of preliminary sense. This isn't obviously a substitute for something like a PCA if we were to go really deep in on looking for clusters and such. Any questions about this? Okay. Before we go into other geoms, I want to mention one other thing. This up here, these aesthetics, these, like I said, are global aesthetics. So no matter what geoms you put down here, it's going to apply to all of them. What this means is you can actually make certain aesthetics geom specific within reason. By within reason, I mean you're not going to be able to put one x-axis in one geom and then have another geom point with a different x-axis. That won't make a lot of sense. You can have two different variables on the same x-axis. But something like, let's say, color equals clarity, you could actually put that down here. So within geom point, you could give it the aesthetics argument, then type in color equals clarity, and remove it from up here. And this will become more relevant in a second when we start adding more geoms, because then it allows you to kind of localize some of your aesthetics. We won't see any change here just yet, but keep this in the back of your mind because it gets really important as you make more complex plots to kind of keep certain aesthetics within certain geoms. Sounds good? All right, so let's actually look at some other geoms. So a common plot you might find yourself making is a histogram. And with a histogram, we can actually use pretty much the same syntax we've been using so far, but only change up the geom. So we would write ggplot diamonds, and let's say we care about the distribution of carat. So what's on the x-axis over here? You would write aesthetics x equals carat, but we don't actually need to provide a y value here because with histograms, by definition, the y aesthetic is the count, right? A histogram will bin the values of carat and then return the count of values that fall within each bin. So you don't provide the y, you just add a plus over here, and then you type in geom underscore histogram. And once we run this, it'll pick an automatic bin width of 30. You can change this later on, or sorry, number of bins is 30 and then subdivide accordingly. But basically what it's done is it's taken all the values of carat, split it into 30 equally sized bins, and it's telling us how many values of carat within the data set fall within each bin. So we can see that most of them are quite low, and there's like a bit of a peak around 1 or so, and then it just kind of diminishes to the point where we virtually have no values up here. Well, virtually, I'm sure there's a few. As with alpha for geom point, geom histogram will also take in some custom arguments. So for instance, if you wanted to change the bin width to, let's say, 0.01, so split it into bins of size 0.01, you could type in bin width equals 0.01. And this is going to be a very, what's the term? Yeah. striated plot. Is that a good word? Words are hard. Any questions about that? So the point I'm trying to get across here is that different geoms will have, although geom histogram will also support an aesthetics argument were we to give it one, they might also have some unique arguments as well. So bin width would make a lot of sense with geom point, right? How do you make bins for a scatter plot? Next up, we'll have a quick peek at a box plot. So going back to our earlier pattern, we saw that clarity seemed to be some sort of determinant of, not determinant, but it seemed to be related to caret in some way. So we might ask, what is the distribution of caret, what's on the x-axis over here, for each value of clarity? So now we can use our ggplot syntax again, and hopefully you're starting to see some of like the logic behind putting this together this way. Diamonds, comma. Now on the x-axis for our box plot, we would have caret. Actually, sorry, my bad. On the x-axis, we have clarity because we're making a box plot. And by levels of clarity, we want to see values, or rather distributions of caret. At the end of that, we'll add the plus, as we did before. And this time, our geom is called box plot. You could actually just type in geom underscore and just scroll through all the many geoms that ggplot is available to you. There's a lot. I think there's still plenty here I've actually never used, but point being, if you can think of a plot, you can probably make it a ggplot. So we'll just type in geom box plot, and we'll run this as is. And here we've got the distributions of caret, this time on the y-axis, for each level of clarity. So we can see that I1, Claire, do you have a question?
Sorry, I was just gonna ask, for clarity, does it take levels that were like defined in the data set for I1, S1, 2, all that? Like, is that already predefined? And you just
Right.
sorted it by that?
Yeah. So if we type in diamonds over here and look at clarity over here, I believe it's already a factor and it's already been ordered in some way. I don't think you actually need these things to be a factor, although don't quote me on that, I might be off.
So if it wasn't a factor, it would arrange them alphabetically.
Yes, right.
So it would just be apparent that like I1 and IF are actually on opposite ends of the spectrum.
Right, yeah, you're right. So for those who might not be familiar, factors are a type of ordered variable in R. Variable, is that the right way to put it? But essentially, when you've got a categorical variable, by turning it into a factor, you can give, you can provide it with levels, which determine the order in which R sees it and then does operations like this. So yeah, in this case, it's already ordered. If in your data it isn't, then you could convert your column to a factor, set your levels, and then that would work. Was that the question? Or?
Yeah.
Okay. Cool. ggplot also has special functions. We won't be covering them today because they're a bit more advanced, but they're called the scale family of functions. In this case, there'd be a function called scale x discrete. And then within that, you could actually set the order, so you won't actually have to change your data frame itself. So that's something worth looking into if you're more interested about axis transformations and such. Any other questions? Okay, how do we feel about geom so far? You'll notice that the syntax is pretty consistent, and if you were to make a line plot, if you were to make a bar plot, we won't be going to those today because there's only so much time we have to talk about ggplot, but they would all start out the same way. You would always start out with ggplot, data frame, aesthetics, and then you would apply your geom. And then you would go from there to maybe add coloring, maybe further customization, which we'll talk about in a second, and other geoms. So I keep saying we're gonna add other geoms. Let's finally sit down and do it. So let's go back to our original plot, our scatter plot. I'll just write out the whole thing again over here. I'm gonna say line fits. So ggplot diamonds, aesthetics, on the x-axis we had caret, on the y-axis we had price, plus geom underscore point. Right? We ran this, we got this big, really crowded plot. We later added the color aesthetic, or the color aesthetic to shade them by clarity. Thought we saw some patterns. Looks good. Now, a very common task you'll find in data visualization, data analysis in general, is fitting relationships, fitting models to your data, right? So does your data, or sorry, started that sentence wrong. Let's say you wanted to plot a linear fit on top of your plot, or quadratic fit, or so on and so on. So the really nice thing about ggplot is it actually consolidates all these line fits into a single function. And then that function is endlessly customizable to pretty much any kind of model fit that you might like. So at the end of this, we're going to tack on, we're going to say geom point plus geom underscore smooth. And geom smooth is the catch-all function for all sorts of fits. The one annoying thing about geom smooth is it will always first try to guess what kind of fit you want, and it will always get it wrong. So what we're going to do is specify that we want a linear fit in this case. So we're going to type in method equals, and then in quotes, lm. And for those that have done regressions in R, you might recognize lm as the function for linear model. And the same kind of meaning applies over here. Generally, pretty much in my entire experience using geom smooth, I have always just manually specified the method. I don't know what it uses to guess, but it's not particularly good at it. And I love ggplot, so I can be upfront about that. If you run this, you're going to get the same scatter plot, but now we get a line drawn through it. This actually alters the y-axis a little bit because ggplot wants to show us, I guess, the line fit a bit better. But this is actually the same line you would get if you were to do a linear regression, use the predict function, kind of that old school style of plotting linear fits. In ggplot, you just specify the kind of method you want. It'll do the fit, it'll plot it for you. And the really nice thing about this is that, remember that color aesthetic we had earlier? Let's add it into these global settings. Color equals clarity. Remember, I'm adding a global setting over here. This is in the original ggplot call. That means it's going to apply over all geoms. And what that means is ggplot is actually fit a separate line for each of these levels of clarity. So not only has it shaded the points by that, it's actually a bit of a messy plot. I might want to reduce the alpha value here. It actually shades, it actually does individual line fits and then colors those line fits in as well. And of course, if you don't want this to happen, if you want a single line fit, but still want your color or your data to be shaded by clarity, this is where that idea of geom-specific aesthetics comes in. Remember? So if I'm to take out color from up here, so that in the global settings we just have X and Y, or global aesthetics, keep saying settings. Then in geom point, if we were to say aesthetics color equals clarity, leaving everything else the same, what do we have on our hands now? We get a single linear fit, but we still get our points shaded in by color. So this is kind of the power of localized aesthetics, right? And then of course there's other arguments as well. So we can make our line red to make it stick out more. So color equals red in quotes. You could actually give it fancier names like steel blue and Dodger blue and whatnot. And ggplot's always just like, I got you, I know what that color is. So that's always pretty nice. All good? Any questions? Give everyone a second here. So of course, if you wanted to do stuff like low S fits, quadratic fits and such, I believe there are like certain shorter letter codes for those, but those I find I always just end up Googling. It's like quadratic fit in R, and then I find a link on Stack Overflow that tells me how to type it up. So if you ever forget these codes, don't sweat it. There's definitely resources online for looking them up.
And of course, the help function.
And the help
It's
function.
there.
Yes, I should mention that, sorry. One other thing, if you didn't already know this, for any function in R, you could always type in question mark and then the function. So in this case, geom smooth. Run this, and then down here in our plots pane, it'll actually switch to the help tab, and we get the entire documentation for geom smooth. So it starts off by telling us what it does, all the various arguments it could take in. You'll notice there's a lot. What each of those arguments means, so what data to display, position, formula, and so on. And then at the very bottom, actually some examples as well. So it's very thorough, and it's all within R. So you don't even have to necessarily open up Google. Cool? All right, so for the last 10, 15-ish minutes of this, I'm gonna go in we're gonna dip our toes a bit into more intermediate ggplot. So far we've covered how to make a basic ggplot, some basic geomes, and honestly, that might be enough for you to just get started with ggplot. It sure was for me. But you might want to make your plots look a little prettier. You might want to customize them in some way. So ggplot actually offers certain built-in themes that you can use to make your plots look a little nicer. So themes. So if we're to just, let's say, copy this whole thing down, and remember, you can actually save all this to an object too. Tell you what, I'll actually do just that. I'll create a new object called P and save this entire plot to it, okay? Now let's say I want to try different looks on this plot. I want to apply different themes to see how it looks. ggplot has a bunch of these themes built in. So I could type in P plus, and then on the same line or a new line, it doesn't really matter. Remember, it's just more whatever looks best to you. Start typing in theme, and then ggplot spits out a bunch. Line draw, minimal, update, void. We could start with theme BW, which stands for black and white. It's like this really kind of minimalist looking one. It's relatively popular for that reason. And what this line will do is it'll plot all of what's up here with the theme BW function added on as another geom. It's equivalent to if you had theme BW over here, remember. But you'll notice this looks quite different, right? The gray background is gone. There's the shading behind each of these points of the legend is gone, and so on. Similarly, there's themes like theme classic, which I don't know if it's supposed to approximate base plot because it doesn't quite do that, but it is quite minimal and nice looking, and one I'm a particular fan of. So theme classic just has the old school X and Y labels, nothing else. No grid lines, no background. So it's a good one to use. And of course, you could actually make your own themes. So making your own themes is something I could honestly go on about for hours. Nobody wants to hear that. But if you were to make your own themes, that would be with P plus just theme, the theme function. And I won't go into this because it's a total rabbit hole and something I love exploring on my own time. But if you were to type in theme and then just hit tab, you can modify all of these things. How the axis ticks look, how big the legend text is, how big the axis text is, whether there's a panel background. So all of these things are modifiable. And they often use these other helper functions known as the element functions. You'll notice over here it says grid lines, element line. If you want to look more into this, the lesson material for this lesson is posted on our website. If you go to uftcoders.github.io, the lesson content tab, and you navigate to the ggplot lesson. But at the bottom, I've linked a bunch of resources, including some that go into how to further customize your plots. But it's a pretty intense subject because there's just so much you can do. Okay, any questions on themes? I guess I should also mention there's, oh yeah,
I'm
questions?
assuming there's a site where you can actually visualize examples.
Yes, there's a site called the R Graph Gallery where people have put up plots and I believe put up code with them as well. So you could visualize how different themes look. People have made custom themes. There's even other packages. I think there's a package called ggpub.r. Was it ggpub.r or ggpubs? ggpub.r. And it has specific themes to actually match certain publications. There's like a 538 theme, an Economist theme, a New York Times theme.
There's also GG themes.
GG themes.
Even more themes.
Yeah. Like I said, total rabbit hole. I've spent so much time playing around with themes. But if you can think of it, someone has coded it up. And if not, it's with a bit of tinkering, you could code it up yourself. So yeah, it's very customizable. And the really nice thing about it is it's kind of, we started with this basic ggplot thing. We defined our aesthetics, we defined our geomes, and then the theme just kind of tacks on. We don't require a separate like function or like some other sort of fancy modifier. It just tacks on as if it were another geom. Before I go into the last thing, which is faceting, I think I should mention one more thing. I don't think it's in the lesson content actually, but it's probably pretty important to mention. The order in which you add these things, the order in which you add these geoms is actually pretty important, especially for geoms that are actually showing up on your plot. Stuff like theme, it doesn't really matter where you put it in there. But so notice here I have geom point first and geom smooth second. And you'll notice that the points on the plot are underneath, if you were to think of this as coming out of the screen, underneath the line. You don't have to do this for yourself, but I'll just do it for you. If you were to switch the order of these, what do you think is going to happen? So I'm going to run that. Since I saved it to P, nothing actually printed, so I will just run P on its own. And now it seems that our jungle of points is actually hiding the line. The line is actually behind the points. So this can be used to your advantage. If you've got many things going on in your plot, you can actually order the way the layers appear, in a sense. So obviously, in my case, and many cases, you will always have points underneath the line in a scatter plot. So I'm just going to switch this back. But it's worth knowing that. It's gotten me out of some like pickles every now and then where I'm like, wow, I just can't see this line. And then I remember I just have to switch the order of the geoms and it'll show up on top. But that's only mostly relevant for geoms themselves. Stuff like theme BW, you could stick in anywhere and ggplot will be happy to apply that to your plot. Okay, so the last thing we're going to cover is faceting. And faceting for me was when I realized just how extensible this sort of syntax is. So I've been harping on for quite a bit about how it seems that clarity affects this relationship between caret and price, right? ggplot actually offers a really nice way to visualize that beyond just shading these points by levels of that variable. Instead, what we can do is split this plot into several subplots by levels of a categorical variable. And all it takes, let's actually write this up, ggplot diamonds, it actually takes one extra, not even a geom, but one extra function. So we'll write the same thing we did earlier. Aesthetics, x equals caret, y equals price. And I'm kind of manually writing these over and over in the hopes that hopefully it gets your muscle memory going, because ggplot is very consistent, and I quite like that. So we'll write geom point. We can, actually we'll just leave it at that. Plus, or sorry, let's just run this on its own, just as a bit of a refresher. If I just run caret, price, scatter plot, I get this whole thing. And I mean, compared to the colorful minimalist looks we've had so far, you can see how far we've come. At the end of geom point, add another plus, and this time write facet underscore wrap. Within facet wrap, we can specify a categorical variable we want to split the plot by. And to do this, you have to use the tilde symbol. The tilde in this context means by, so as in facet by, and then in this case, clarity. Right? And if I'm to run all of this, I go from one plot to how many is that? 8. It's really scrunched up on my screen. Hopefully it looks a little better on yours. You could also click on the zoom button over here to make it a bit bigger and see it a little better. But this allows us to see that, you know, for instance, for I1, the relationship seems to be quite different, right? Like compare the slope of that versus this. So faceting is really useful for visualizing how a categorical variable affects the relationship between something else. But not only that, it just took us one extra line of code. And that really is like one of the nicest things about ggplot. Another fun thing you can do, in fact, is you could actually provide the color aesthetic at geom point just for fun. You could give aesthetics color equals clarity. And what ggplot will do is it'll color the points by clarity, but then it'll facet them anyways. This is something I like to do just to make my plots prettier. We're already separating them, but it'll give each of these a different color. And then you can potentially get rid of the legend if you'd like. Well, that to me looks quite a bit nicer. Of course, it's completely redundant, but still. The final thing, though, is so far we've been dealing with one categorical variable. What if we cared about how 2 variables affected a given relationship? This is where the other facet function, so I'll type this out again. You could just copy down the line so you have above, x equals caret, y equals price, plus geom point. I won't color it in by anything just yet. And this time, instead of facet wrap, try facet underscore grid. Facet grid allows us to provide 2 variables, which will essentially make a grid with one categorical variable on the sort of x axis of the grid and then one on the y. So what we'll do this time is cut tilde clarity. So cut by clarity. So with these 3 lines of code, we're going to visualize 4 variables doing their thing. And once you plot that, you get this whole matrix of how caret by price looks across all combinations of, of clarity and of cut, which is pretty neat. I think it's pretty neat. Of course, you could get funky and add more color aesthetics to geom point if you'd like to color this up the same way as earlier. You could also, as before, add themes to this. So theme underscore minimal. And then ggplot will apply that theme to every one of these subplots. All 40 of the subplots. That's 40, right? Math is hard. Yeah, just had the themes applied to them. Any questions about that? Cool. All right. That is more or less what I wanted to cover today. I didn't want to go too far, given we only really had an hour. But I hope this was like a good enough introduction that you can get started with ggplot, kind of understand its sort of layered syntax, and go wild with your plots. So with that, we'll wrap up the lesson. I'm happy to take any questions now, and I'll be around for questions if you'd like to come up afterwards and ask them as well. But otherwise, yeah, thank you guys for coming. Cool. So are there any final questions? Yes.
Sorry, could you explain the difference between facet wrap and facet grid?
Yes. So with facet wrap, it's used for one variable.
Okay.
Facet grid expects two, because it's going to make a grid out of these.
So how would it know which two were to use?
Because we've specified them over here, cut and clarity.
Oh,
With the tildes.
okay, sorry, I thought
And-
that was something else.
That's all good. And I believe if you actually type in facet wrap with just one variable, it'll just make like a whole row of them. Whereas facet wrap actually, splits them up a bit. Like, let's look back at it. Sorry, before the theme. So you'll notice it like splits them up like this. If you used facet grid, it's trying to make a grid, but if you only given it one variable, it'll just be like,
Okay.
which will kind of look horrible if you've got a lot of different different variables.
And is there any way we could reorganize the position of those?
Yeah, so I believe that again is using reordering them, reordering the factors themselves.
Oh, okay, from the data and not the.
Yeah, I'm trying to think if there's a ggplot way to reorder facets, and I can't remember. But which there might be. We can look that up together afterwards. But yeah, if not, then reordering the data will definitely work. And we can see over here actually that this is ordered the way the factor is, and that's why we've got I1 over here and IF at the end, even though alphabetically they should be right next to each other. Yeah. Any other questions? Yeah.
For the geom smooth, why are the arguments values? Why are they strings compared to like aesthetic X?
Right.
Caret?
Yeah, that's a good question. So the question was, why are the arguments to geom smooth over here? Why are they strings when these other arguments are not? The reason for that, and this is kind of a general philosophy seen in not just ggplot, but other packages that are part of this thing called the tidyverse, where generally when they work on data frames, any argument that refers to a data frame column is not in quotes. It's just written out as an object. And then these are evaluated kind of under the hood in a nice, clean way. So whenever in this tidyverse, or in this case ggplot world, you're referring to column names specifically, you won't have quotes. But in this case over here, since LM refers to the style of linear fit, since red refers to the color, those still need to be in quotes. So it actually only really applies to column names, the no quoting thing. Yeah, and if you ever use the package dplyr, then it works similarly in that it expects all column names to actually be just written out as is and not in quotes. And the purpose of that is actually to make typing them up easier. Anything else? All right, cool. I guess I will unplug my laptop and we'll wrap things up. So thank you again for coming. Next week is our statistics in R lesson. And then after that, we'll have a series of Python lessons and so on and so forth. Our schedule is available on our website. We've got a couple lesson series across the rest of the summer. Question? Or?
Can I ask you one question? I think it's probably more basic.
That's fine, yeah.
I was just wondering, I know anytime I've used like these sort of functions, it's always with like a quite a big data set that
Mhm.
is downloaded and I'm always just kind of like coding along. So
Right.
using ggplot, like say I had some of my own data like Excel,
Hmm.
that had like one X variable, and
Right.
then for that maybe like 3 Y variables, and I wanted to like graph that and
Sure.
would I just be able to like import new data set from, and then would I assign the variables? Like would R know, like for example, with the diamond data set, it says like clarity, like
Yeah.
when I import it, would it say, for example, like concentration
Mhm.
and viability or that sort of thing, or do I have to like assign that?
Right. Yeah, that's a good question too. And it's something, it's not like basic reading in data files is still something that gets really messy sometimes, depending on how they're formatted. So if you want to import something from Excel, you'd have to export it from Excel as a CSV file. I don't know if you've used those before. Yeah, so CSV files are what R likes, whereas Excel spreadsheets like the XLS file format, I believe they're packaged to deal with it, but generally R is a little more messy when dealing with those. So if you export it as a CSV, there's a function called read CSV. And what you can actually do is use that to, so read CSV, the input argument it takes in would be a file name. And once it does that, then you'd have to assign that to an object. You could call it my data, for instance. As for your questions about headers, so if the columns are formatted kind of similar to our diamonds data set over here, with let's say in your Excel spreadsheet, the first row is the names of the columns, and then the remaining are the data. R is good about inferring that. But sorry, you were just saying?
No, I was just gonna say, so like after I learned to export it as a CSV, then read it in, like assign it to an object,
Mhm.
and
And then you could use those column names, yeah.
then, okay,
Yeah.
so you would recognize it.
Yeah, it only really bugs out when the number of kind of data columns is different from the number of columns up there, which often happens because people often put metadata, stuff like, you know, this was collected on this date, and then the column names, because R will always look at the first row.
Okay.
Yeah, and then sometimes it'll still like, if there's special characters, if there's like an E with an accent on top, or then sometimes it misbehaves. So there are still ways for you to make R read in a data file. You can provide your own column names as you read it in. So read CSV takes that as an argument. You could also even make R skip the first few rows of a CSV.
Okay.
So if your first 2 rows are this data is important and I will use it in this, and then the data starts within read CSV, there's actually an argument, which here we can look it up, read.csv. So the skip argument will allow you to skip lines, and then col.names will allow you to set column names if it doesn't guess them correctly. Yeah. So these things are important to be aware of because R can sometimes be like a little moody about data files. And you'll notice, oh, there was an extra space there, or but this was the way to go.
Okay.
Yeah.
And if there were multiple like Y values in the data, would it interpret that like
Mhm.
separately? Would it take like a mean if I were like making a plot?
Right. I mean, are you saying multiple Y values in the same plot, or?
So for example, like if at one, say a concentration,
Mhm.
there were 3 different, like of n equals 3 for like viability of something done like in triplicate, for
Sure.
example, would it average them?
No.
Or would
It reads them in the way you've kind of written them out in your Excel file. So the thing with, for instance, diamonds is R doesn't have any idea which of these is supposed to be an X variable or a Y variable.
Right.
And for instance, you'll notice that earlier when we did the box plot, we had caret on the Y, but so over here Y equals caret, and in pretty much all other instances we had caret on the X. So R doesn't try to guess like what your response and your predictors are, but you can specify those in stuff like ggplot when you're doing linear fits and so on.
Okay.
Yeah. So it'll just read your data as is, and it will try its best not to make any assumptions about it. So by try its best, like I mentioned, sometimes it's moody when it's reading in data, but that's what these kind of special arguments are for. But otherwise, like when you're plotting, you have complete control, which is quite nice.
Thank you.
Yeah, no worries. Any other questions? Cool.
I'm just
Sure.
curious about what topics will be covered in the stats
So we're still waiting on the instructor to get back to us for that one.
Oh, okay.
Last year, oh, sorry?
No.
Yeah, last year what was covered, it was taught by a different instructor last year, was less stats in R because you can't, teach a whole stats course in an hour, but more how to implement basic stats in R. So how do you do a linear regression? How do you get summary stats? How do you do an ANOVA? How do you get type 3 sums of squares instead of 1? So stuff that kind of assumes you know stats already, but want to know how to do it in R.
I was wondering, would there be stuff on like principal component analyses or something?
Likely not. Not for next week's lesson, but if that's a lesson you're interested in, then let us know, and then
Okay.
for next semester we could think about that. All right, for everybody else, thank you again for coming. If you haven't filled out the attendance sheet, which I think most people have, but if you haven't, please make sure to do that. We'd really appreciate it. We've got snacks over there as well as some stickers. Please help yourself to both. And otherwise, we'll hope to see you next week.